Okay, I'm here in volume number 1, Google Jamboard, and we'll first talk about some key terms. So remember that a polygon is a closed figure formed by 3 or more line segments, right? They are shapes that are closed, they have straight lines, and they're flat shapes. They're two-dimensional figures. Like triangles would be a 3-sided polygon, quadrilaterals like a rhombus or a trapezoid or a square or a rectangle, something like that. 5-sided polygon like a pentagon, and so on. All of those are polygons. We also have something called polyhedrons. Polyhedrons are not two-dimensional, they are three-dimensional. They are three-dimensional solid figures made up of polygons. So once you start putting polygons together, then you have a three-dimensional figure. Here are 3 of them. We have first a right rectangular prism is what this is called. It is a polyhedron with 3 pairs of congruent and parallel rectangular faces. So the top rectangle is parallel to the bottom rectangle. This rectangle on the side is parallel to the other rectangle on the side. The rectangle on the front is parallel to the rectangle in the back. They're not only parallel, but they are also congruent. So figure A is a right rectangular prism. Figure B, we have here a cube. A cube is a special right rectangular prism because it is a polyhedron that has congruent squares as faces. So as the right rectangular prism has rectangles as faces, rectangles or squares, a cube has all squares as faces. Figure C, here we have a rectangular pyramid. A rectangular pyramid is a polyhedron with one base. It has one base and the same number of triangular faces as there are sides of the base. And so as you can see on the base, there's 1, 2, 3, 4 sides. And so I have 1, 2, 3, 4 triangular faces. Here are some other key terms. We have a face. A face is basically where one polygon, a face is one of the polygons that make up a polyhedron. So, like in prisms, there are 6 faces, right? The front, the back, the sides, and the top and the bottom. Same thing with a cube. And in figure C, there are 5 faces. Of course, we have the base, and then we have 4, 1, 2, 3, 4 triangular faces. And so figure C has 5 total faces, but they are the polygons that make up the polyhedron. An edge is the intersection of 2 faces of a 3-dimensional figure. So like in figure B here, this cube, this right here would be an edge. This is an edge. This is an edge. This is an edge. Okay, it's where the faces meet. The vertex is the point where the multiple edges meet. And so like it's the corner of the figures. And so like this is a vertex, this is a vertex, that corner is a vertex, that corner is a vertex, and so on. If you have more than one vertex, you don't have vertexes, you have vertices. So vertex is singular, vertices is plural. All right, so that's some key terms to keep in mind as we talk about volume. Volume is the amount of space occupied by an object. And the volume of an object is measured in cubic units. And so in our previous module, we found the area, which was measured in square units. The volume is measured in cubic units because we're multiplying not 2 units together, we're multiplying 3 units together. And so we can calculate the volume of a cube, for example, by taking the length times the width times the height. So here's the volume of a cube. Volume of a cube, L times W times H. Length times width times height. And so here we're going to calculate the volume of the cube. Remember, in a cube has all sides that are the same. Every edge is the same length. And so it has the same length, the same width, and the same height. So in part 1 here, calculate the volume of each cube with the given side length. So if our side length is 9/10 of a centimeter, that 9/10 of a centimeter is our length, our width, and our height, because in a cube, it's all the same length. And so I need 9/10 times 9/10 times 9/10. Right? The length is 9/10, the width is 9/10, and the height is 9/10. And so if I just calculate or multiply my numerators, 9 times 9 times 9, that would give me 729. And on the bottom, 10 times 10 times 10, that would be 1,000. So this would be 729 over 1,000. And then my label here is going to be centimeters cubed. Centimeters cubed. So my exponent is 3. This is cubic centimeters. Part B here, I have a cube with 1 1/3 length of sides. And so I would multiply 1 1/3 times 1 1/3 times 1 1/3. And if I multiply mixed numbers, I need to first use the C method to make them improper. So if I make 1 1/3 improper by using the C method, I would get 4/3. That's the length times 4/3 the height times 4/3 the 4/3 the length, 4/3 the width, 4/3 the height. Multiply the numerators, 4 times 4 times 4, that is 64. And on the bottom, 3 times 3 times 3, that is 27. So I get 64 over 27, and because this is improper, I can make it mixed by dividing the top by the bottom. So 64 divided by 27. 27 goes into 64 twice. 2 times 27 is 54. I would subtract and get 10. And so that's going to be my numerator. 10 is my numerator. 27 is my denominator. So I get 2 and 10/27. And again, this is centimeters cubed. Centimeters cubed. And I'll circle that final answer. Okay, so that's how to find an area of a cube. Length times width times height. And in a cube, every side length is the same. Number 2, calculate the volume of the rectangular prism. Okay, so here's a little note over here. It says the process of finding the volume of a 3-dimensional figure is similar to the process of finding the area of a 2-dimensional figure, except that now you're multiplying 3 dimensions, right? Before, when we found the area of, say, a parallelogram, we did base times height, or of a rectangle, we did length times width. We multiplied 2 dimensions together. Now, because we have a 3-dimensional figure, we multiply 3 values together, the length, the width, and the height. Okay, and also volume is measured in cubic units like we just discussed, whereas area is in square units. So here I have a length, I'll put L for length, a length of 1 1/2, a width of 1/2, and a height of 3/4. So to calculate the volume, I do length times width times height. Okay, so I need 1 1/2, 1 1/2 times 1/2, which is the width, times 3/4, which is the height. Okay, 1 1/2 is a mixed number. Let's make it improper by the C method. So if you use the C method, I would get 3/2. 3/2 times 1/2 times 3/4. I look and see, can I cross simplify? I can't. So I'm just going to multiply straight across. 3 times 1 times 3 is 9. On the bottom, 2 times 2 is 4. 4 times 4 is 16. So I get 9/16. What's my label? Please be sure to label. This is inches what? Inches cubed, right? Cubic inches. That is the volume of this rectangular prism. Number 3 here, calculate the volume of a rectangular prism with the dimensions below. And so if it's this by this by this, that's telling me the length, the width, and the height. And we know that if we're multiplying, it doesn't really matter what order we multiply in. I could do H times W times L, or H times L times W, because when you multiply, right, you'll get the same product. The order does not matter. So because these two are mixed numbers, let's make them improper so that we can multiply. So 1 3/4, by using the C method, I would get 7/4. Multiply that by the width. C method, I would get 7/3. Here I just have the fraction 1/2, so 1/2. I look and see, can I cross simplify? I can't. So I'm going to multiply straight across. On top, I got 7 times 7 is 49. 49 times 1 is just 49. On the bottom, 4 times 3 is 12. 12 times 2 is 24. Okay, so I get 49 over 24, which is improper. So let's make it mixed by dividing the top by the bottom. So 49 divided by 24. 24 goes into 49 twice because 2 times 24 is 48. I subtract and get a remainder of 1. So my mixed number is 2 and 1/24. And what's my label? This is inches what? Because volume is in cubic units, this is inches cubed. 2 and 1/24 inches cubed. Number 4, calculate the volume of the right rectangular prism. Show your work for how you multiplied the length times the width times the height. Okay, so I have length, I have width, I have height. I'm going to find the volume. And so I could say area of base times the height, right? I could say, like we just discussed, area of base, so capital B times H. Well, how am I going to find the area of the base? The base is this rectangle, right? I know that this face is the same as the face on the bottom. So to find the area of that, I would do length times width. And length times width will give me capital B, area of the base. So I need to do 32.64 times 7.3. Okay, and I would work this out. All right, so 3 times 4, that's 12. Notice how I'm showing my work here. 3 times 6 is 18, plus 1 is 19. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9. So 9, 7, 9, 2, that's my first row. Second row, I'll add placeholder 0. I've used that digit I carried. I've used that digit, and I've used that digit. 7 times 4 is 28. 7 times 6 is 42, plus 2 is 44. 7 times 2 is 14. 14 plus 4 is 18. 7 times 3 is 21, plus 1 is 22. So when I add, I get 2. 9, 8, 17, so carry the 1. 1 and 7 is 8. 8 and 4 is 12. 1 and 9 is 10. 10 and 8 is 18. Okay, so I get 238,272. How many digits were after the decimal? I had 2 and then 1 more. That's 3. And so there should be 3 digits after the decimal in my answer. So 238.272, that is the area of the base. That is capital B, right? That is length. That is length times width. My final step to get the volume is to then multiply this by the height. Okay, so let's do that. I would have 238.272 times the height, which is 10.1. So multiplying by 10.1. Okay, so I got, basically I'm multiplying everything by 1 here. 1 times 2 is 2. 1 times 7 is 7. 1 times 2 is 2. 1 times 8 is 8. 1 times 3 is 3. 1 times 2 is 2. Placeholder 0. Now I'm multiplying everything by 0. So 0 times 2, 0 times 7, 0 times 2, 0 times 8, 0 times 3, and 0 times 2. Okay, so done with that one. Third row, add 2 placeholder zeros. 2 placeholder zeros. 1 times 2 is 2. 1 times 7 is 7. 1 times 2 is 2. 1 times 8 is 8. 1 times 3 is 3. Kind of out of room here. 1 times 2 is 2. Squeeze that one in. Okay. Add. I get 2, 7, 4. This is 15, so put a 5, carry the 1. 1 and 3 is 4. 4 and 2 is 6. Here I have 2 and 8, which is 10. 1 and 3 is 4. And then just a 2. Okay, so let me use text box here. I got 2406. And then now I need to place my decimal. It looks like I have in my answer, I should have 3 after the decimal plus 1 more. So that's 4 total. 1, 2, 3, 4. The decimal should be after the 6. So back to my text box here, I should have 2406.5472. Okay, and label my answer here. It's in meters cubed. That is the volume of this right rectangular prism. Okay, last one here I'll talk about is in number 5. I'm just placing my decimal. Each number sentence represents the base, which is area of base, a capital B means the area of the base, right? Not to be confused with a lowercase b, which is like the length of the base in a triangle. Okay, so complete each number sentence by inserting a decimal point to show the correct volume. So you got this number times this number, so where should the decimal go in this number? You got this number times this number, so where should the decimal go in this number? You got this number times this number, so where should the decimal go? Okay? You can either put the decimal there, or you can over here type in a text box where the decimal should go. I would actually prefer that. So over here, type in a text box where the decimal should go in this answer so that I can see where you put the decimal. Number 6, you're adding. So line the numbers up vertically and add them. I should be able to see if you carried numbers, how you carried them. Here you're subtracting. Line the numbers up vertically. If you borrowed, I should be able to see how you borrowed. Multiplying. Here we're dividing. So first number goes inside the division bracket. Second number goes outside. Okay. You got a decimal outside the division bracket, so you got to move the decimal one place to the right, of course, on both numbers, so that you do not have a decimal outside the division bracket. Now I rewrite the problem. The number inside is no longer 7.8, it's now 78, and the number outside is no longer 2.4, it is now 24. Okay, so 78 divided by 24, write your answer as a decimal. Once you've shown all your work, then you'll click Turn In.